Hello and welcome to this presentation about the Kerberos Authentication protocol. So let's dive straight into it. What is Kerberos? As I said, Kerberos is an authentication protocol. This means that it's a protocol that ensures that the server or client don't fake their identities when they are communicating with each other. And it can also help a server to check if a client has the right access permissions. And Kerberos is used today in a lot of different software projects. For example, the Windows Active Directory, the network file system, the Kafka message broker, and Samba. Kerberos was developed at the Massachusetts Institute of Technology. Version 5, which is also the current version, was released in 1993. So this indicates that it's a very stable protocol, since this was almost 30 years ago. And there is an open source implementation of Kerberos, which is actively maintained. And this development is sponsored by companies. For example, Google, Apple, and Microsoft are part of sponsoring this development. A fun fact about the name Kerberos. Kerberos is also the name of a dog in Greek mythology. This dog is said to have 3 heads, and it guards the underworld so that dead people don't get out of there. And I guess they chose this name because in Kerberos there are 3 types of entities, namely server, clients, and key distribution center. Here is a high-level view of how a system that uses Kerberos authentication might look like. We have a number of clients. In this case we have client 1 and client 2, and a number of servers. In this case it's server 1 and server 2, and then we have the key distribution center, or KDC for short. And as you can see, all the clients and servers have their own key, which is indicated by this key symbol with different colors. And the key is a key used to encrypt messages, so you can look at it as a password as well. And the key distribution center, it knows which key all the clients and server have. So you see here there is a mapping between the client and server IDs and their keys. And in the Kerberos protocol, the clients connect to the KDC when they want to authenticate themselves to prove that they are who they say they are, and when they want to get a ticket for accessing a servers. Servers, they never need to contact the KDC in the Kerberos protocol. I will now illustrate how the Kerberos protocol works by showing you a concrete example. In this example, client 1 up here wants to authenticate itself and get access to server 1 down here. And we have the key distribution center. The key distribution center can be divided into 2 parts: the authentication server and the ticket granting server. And these 2 servers share one key, the yellow key here. We'll see soon why this is important. And even though these 2 servers can run on different machines, they are usually run on the same server machine. So conceptually you can think of the KDC as a single entity. Now back to the example. So the first step is that the client 1 wants to authenticate itself to prove that it is actually client 1, and for that it sends an authenticate message to the authentication server. The authentication server gets the message, and then it responds with another message which contains a session key, the gray key here that it has just created, and it encrypts the session key with the client's key, the red key. So you see the red lock illustrates that it's something is locked with the red key. And then in the message they send back to client 1, there is also a ticket called a ticket granting ticket, and it also contains the session key and the ID of client 1. Now the only way for client 1 to proceed is to unlock the session key. So it can't proceed from here unless it is actually client 1, because if it's not client 1 it wouldn't have the red key. Now once client 1 have got the ticket, granting ticket, and the session key from the authentication server, it will proceed by creating this message you see here. It contains the ticket granting ticket that it just received, and it also contains this access part of the message, which is encrypted with a session key. And inside this encrypted part is the information that client 1 wants to access server 1. When the ticket granting server have received this, it can decrypt this ticket granting ticket as it has this yellow key which is shared between the ticket granting server and the authentication server, and then it can get the session key and decrypt the access part of the message, and then it can check that client 1 is the client which the ticket granting ticket was issued for. It can also check that client 1 should get access to server 1. Once it has validated all these things, it can create a response for client 1. The response contains a service granting ticket, as you can see here, and it is encrypted with server 1's key, the blue key, and inside the service granted ticket is also a newly created session key, the black one that you see here. This session key is also encrypted with the old session key and sent back to client 1, which can of course decrypt the new session key. So now you see here that the client 1 have the service granting ticket and the new session key. With that, it can send a message to server 1 requesting that it want to authenticate itself. And server 1 can verify that client 1 has permission, because it can check this service granting ticket, which must have been created by the ticket granting server, because only server 1 and the ticket granting server have server 1's blue key. So it sees that this service granting ticket contains client 1. And then, since the service granting ticket also contains this black session key, it can decrypt this second part of the message and verify that this is an authentication request from client 1 to server 1. And now it's only one step left, and it is for server 1 to send back a message to client 1, which is encrypted with a black session key saying that it got access. So this is how clients can authenticate themselves to servers using the Kerberos protocol. As you can see here, client 1 can store the ticket granting tickets and service granting tickets that it has got from the key distribution center, and this can be reused later. For example, if client 1 wants to get access to another server, it doesn't need to request a new ticket granting ticket from the authentication server as long as this ticket granting ticket hasn't expired, because these tickets, they have an expiration time, and after that time they will no longer be valid, and the client will have to request a new ticket from the servers. And also, if client 1 want to authenticate itself again later to server 1, as long as this service granting ticket hasn't expired, it can just go to server 1 without accessing the key distribution center at all. So this makes the Kerberos protocol quite efficient. Now, when we have got a basic understanding of how the Kerberos protocol works, we can talk a little bit about some reasons why one might want to use Kerberos. There is a single place where one defines all authentication in Kerberos, that is inside the key distribution center. This makes administration easy, since one only have to change one place. If one, for example, wants to add a client or a server or change some access rule. And another advantage of Kerberos is that servers don't need to know any passwords of the clients. Passwords or keys are never sent in plain text between different entities. And also, the Kerberos protocol is efficient. As you saw, clients seldom need to connect the KDC only when their ticket granting ticket expire, or they don't have a non-expired service granting ticket for a particular server. The protocol ensures mutual authentication. The client can be sure that the server is the one it's supposed to be, and also the server can be sure that the client is the with ID provided in the message. And then there are also some drawback with the Kerberos protocol. So one drawback is that it requires a trusted third party, namely the KDC. If someone get access to the KDC that is not supposed to have access to it, and they can read all the keys for the clients and server, the whole system is compromised, and that hacker can pretend to be any server or client. And another thing that at least is worth being aware of when one is starting to use Kerberos is that it can be a problem if computers don't have their times synchronized, because that can make the tickets invalid when they are supposed to be valid, and this kind of problems, as there is a time in the tickets indicating when they become invalid. Finally, I just want to give some creds to EMQX. This is the company I worked for when I did the base material for this presentation. I also want to mention the Wikipedia page for the Kerberos protocol, and this contains very good information, including an illustration of something that is very similar to the example I provided in this presentation. So I recommend you to have a look at this page if there is some detail you didn't understand or want to know more about. You can also read the Wikipedia page about the dog Kerberos from the Greek mythology. Thank you very much for listening. Hope it gave you something valuable. Bye bye.